Hi students, in this video I want to tell you a little bit about quadratic functions. You've seen these before. They're just parabolas. They're called degree 2 polynomials, which means the degree of the x variable is just 2. So this might be review for most of you. But let's go ahead and check some out. We're going to study quadratic functions in two different forms. One is called the standard form. This looks like a normal polynomial, a coefficient times an x to the power of 2, plus a different coefficient times x, plus a constant term. We're also going to study something called the vertex form, and you'll see why we call it that in the next video. But here we'll have a coefficient, then we'll have x minus something quantity squared, plus some constant terms. So this might remind you of completing the square. That's going to be pretty important, so if you need some review, watch the completing the square video again. Okay, so the first thing I want to do is just make some basic observations about how these graphs look, the graphs of these functions. So first of all, hopefully you can see this calculator here. I want to graph a couple of different functions. Let's first graph two that are in standard form. If I put in 2x squared plus 3x minus 1 and graph it, I absolutely get a parabola. And you'll notice that it's facing upwards. It's smiling. Now I'll leave that one, but I'll also graph a different equation, one where the first term is negative 2. The leading coefficient is negative. Negative 2x squared plus 3x minus 1. And we'll look at this one. So that one is frowning. The only thing different about these two expressions is the sign of the first term. So we might guess that if a is positive, the parabola is facing up. If a is negative, the parabola is facing down. Let's make sure that that's also true if we're graphing in vertex form, because vertex form looks a little bit different, so it's worth checking. So let's try 2 times x minus 1 quantity squared plus 1 and negative 2 times x minus 1 quantity squared plus 1. So we'll take a look at these. The first one to graph is the positive 2. It's facing up. And that's the negative 2. It's facing down. So I would say, yeah, it's probably true that if the first term is positive and the second term is negative, and if the first term is positive, it's facing up. If the first term is negative, it's facing down. Now, why would this be true? Well, if we stare at this vertex form for a moment, whatever x minus h is, we're going to square it so it's positive. And so if a is positive, then this whole term means that this is just a shift factor, right? The plus k is a shift factor. So as x gets bigger, we're growing. Also, as x gets more and more negative, this quantity is getting bigger, so we're growing. So the whole thing has a minimum value, which means it faces up. So let's record that. If a is bigger than 0, then the parabola smiles or faces up. It has a minimum value. So it looks something like this. And this point is the minimum, the smallest. Now, if a were negative, then since this is positive, as x is getting bigger or smaller, this whole thing is getting more and more negative. So it's going to have a maximum, and the parabola will face down. So if a is less than 0, then the parabola frowns or faces down and it has a maximum of biggest value. So it looks like this, and this point is the maximum. So these are just some very simple observations that we can make by looking at the graph. Now I want to talk about, so here are the two forms again, standard versus vertex. I want to talk about how to go back and forth between them. So let's say we have an expression in vertex form. So in this case, comparing, we have A equals 3, H equals 1, and K equals 2 in our comparison. So let's put it into standard form. The way that we do this is just multiply it out. So that's the strategy. So the first thing that I'll do is I'll deal with this term. So I'm going to have 3 times x minus 1 squared is going to be x squared minus 2x plus 1. You can check that by foiling, and then I still have this plus 2 left. And now I have to distribute the 3 to each of these terms. So I have 3x squared minus 6x plus 3 plus 2. So I have 3x squared minus 6x plus 5. So here, if I compare with the standard form, I have A equals 3, B equals negative 6, and C equals 5. So H and K are not directly related to B and C. They're not the same. But this A from the vertex form will be the same as the A from the standard form. Now what about in general? So my strategy again is just multiply it out. So what I find is that I'm going to have A times x squared minus, just by foiling, I'll have x times h and then minus x times h again, so minus 2hx plus h squared is the last times the last, plus k. Multiplying this out again, I have a x squared minus 2ahx plus a h squared plus k. So this is my constant term. This is the coefficient in front of x. This is the coefficient in front of x squared. So a equals a, b equals minus 2ah, and c equals ah squared plus k. Now going in the other direction, if I have something in standard form and I want to convert to vertex form, well, I need to take this expression and I need to write it as x plus something, quantity squared, plus some junk. Look familiar? This is completing the square all over again. So I'm going to have to add, so this is my end goal. So I'm just going to put it in brackets. So I have x squared plus 4x plus something. Then I'm going to have to subtract off that same something so that this all adds up to 0. So how do I figure out what to put here? You might remember that I'm supposed to take the middle coefficient, divide it by 2, and square it. So what I put here is 2 squared, which is 4. Then I need to subtract 4, and I get 3. So the first 3 terms factor to a square, x plus 2 squared, and what's left over here is minus 1. So I have x plus 2, quantity squared, minus 1. So in this case, h is minus 2, and k is minus 1. So the strategy to go from vertex to standard form is to complete the square. In the next video, we'll talk about the differences between the standard form and the vertex form and why it's sometimes more useful to see things in the vertex form rather than the standard form. And like I said, I'll tell you why it's called vertex form. It's pretty obvious once you see it. See you next time.